It's section 5.2 today. It's going to be a continuation of section 5.1. If you liked graphing last time, then guess what? You'll like this section too, because we're doing more graphing. If you enjoyed chapter 1, I'm glad, because all that stuff from chapter 1 is going to come back. So I thought I'd just start today's lesson by just recalling what you learned from last section. In last section, we looked at two new graphs, the graph of y equals sine x and the graph of y equals cosine x. And I already drew a nice little sketch for you here. Remember, the key parts of sine x starts at 0, goes up to 1, then down to 0, down to -1, then ends at 0 with 2 pi. Notice the x-intercepts for y equals sine x are located at 0, pi, 2 pi, or in general form, we did something like this, I think, last day, pi n, where n is an integer. Notice the y-intercept for the sine graph is at 0, where for cosine is a little bit different. It starts up high at 1, then it goes down to 0, then -1, then 0, then ends at 1 at 2 pi. The x-intercepts for cosine are a little bit different, pi over 2, 3 pi over 2, and so on and so forth. And if I want to write something in general terms, that would be pi over 2 plus pi n, where n, once again, is an integer. The y-intercept for cosine, of course, is 1. Now, there are some common features to both of these graphs, and I hope you remember this from last day. The maximum value, well, if you don't remember, just look at the picture. Yeah, it's 1. The minimum value, yep, it's -1. The amplitude was the distance from the max to the middle, or that, I guess, middle axis there. In this case, it's 1. And the period, 1 cycle, think of that unit circle, it's 2 pi. Okay? And then last day we introduced something new. We introduced the a value and the b value, and those affected the following things. The a value changed the amplitude, right? That was the a value. And then the b value would change the period, okay? That was the b. So that's what we did last day, and if you think about that and you refer that back to chapter 1, we actually fiddled around with the vertical stretch and the horizontal stretch, right? The vertical being amplitude, the horizontal being period. Well, what else did we do in chapter 1? You guessed it, we did some shifting translations. Remember how in chapter 1, if I took a function and I added a number to the end, this plus d, what happened there? Oh yeah, if you said it was a vertical translation, you are definitely correct. And don't forget, you can either go up or down depending on if d is positive, right, or negative. So the idea is you go up and down d units. Well, it's the exact same thing here. So notice I've got in investigation number 1, I'd like you to do some practice with sketching y equals sine x. And then I've got these two other graphs, y equals sine x plus 0.5 and y equals sine x minus 1. Why don't you go ahead and sketch those out? I think you can do this on your own. I'm going to make sure, though, I'm going to put the units on my axes here, my vertical axes. Or axis, I should say. Okay, go ahead and try this on your own. I'm going to color code these because I like to color code. 0, 1, 0, -1, 0. Whoop, whoop, whoop. Yeah. Oh, that part there's not that good. Let's try again. Whoop. Ah, that's no good either. Not having a good day graphing. Whoop. You get the picture. The next one, y equals sine x plus 0.5. 0.5, that means I just shift everything up 0.5. That's better. And then y equals sine x minus 1, that means I shift everything down 1. Down 1 unit. down 1 unit, down 1 unit, down 1 unit. Ooh. Pretty straightforward, right? Okay, I hope your graphs look like mine. I hope they're as colorful as mine. Let's just quickly summarize before we move on. When comparing y equals sine x plus d, or I guess I could say cosine x plus d. Okay, I just use sine in this example, but we can use sine and cos. What happens is you now have a vertical translation. Now in the trigonometry world, there's a special name for this vertical translation. They call it the vertical displacement. Okay, this is the terminology they use in trig. Don't ask me why they changed it. Okay, but maybe it sounds more sophisticated. Now notice if d is bigger than 0, then of course the graph goes up. And if d is less than 0, the graph goes down. Alright. If you can remember what we did in chapter 1, you should remember what we're going to do next. So now I'm going to recall in chapter 1 how if we had the form y equals to f of x minus c, notice I'm changing the x value now and compare that to the original y equals f of x graph. That meant we had a horizontal. I knew you were going to say that. And of course you can translate right or left, and I'll use the letter C, units. Now it's the same here. Okay? So, in this case, I'm going to ask you to sketch one period of cosine, and then do these crazy shifts. X minus pi over 3, x plus 4 pi over 3. Now remember which one goes left and right? Remember the horizontal one's the one that's weird, okay? Remember we do the form x minus c, so in this case I'll just make a little note for the x minus pi over 3. That means you're going right pi over 3 units. And the other one here, x plus 4 pi over 3, that's going left 4 pi over 3 units. Okay? Alright, let's graph out cosine x first. Starts at 1, goes to 0. Whoops! What did I do wrong there? Notice I changed the scale here. Oopsie daisies. Remember, the period is 2 pi, so it ends up here halfway then. Remember that? You know what? I should draw that box for you again. Box, cut the box in half, half, half. And then now I'll just put in those values. There it is, there it is, there it is. I'm going to erase my box now. And then now I can just sketch my graph in. Make it curvy. Nice and curvy. There you go. So if I go right pi over 3 now, notice what I did here in my units. Each little square on the x seems to be what? 1, 2, 3. So 3 squares to give you pi, so each one of them must be pi over 3. So if I were to move right pi over 3, I'm just going to go 1 unit to the right on my little graph. So let's go 1. I guess I should move this 1, move this over 1, move this over 1, move this over 1. And now I'll have my graph of y equals to cosine bracket x minus 3, close bracket. It's a shift to the right, pi over 3 units. Once again, I'm only sketching one period. You can do more if you want, okay? Going left 4 pi over 3 means I think I go, let's see, 1, 2, 3, 4 pi over 3 to the left. So that's 4 to the left. 1, 2, 3, 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 4 to the left. Sketch. Okay, there you go. There are your sketches. Okay, Make sure you can label those in your notes so that you know which one's which, or, like me, use colors. Let's just quickly summarize this then. When comparing y equals sine x minus c or y equals cosine x minus c to the original graphs of sine x and cosine x, what do we have here? It's a horizontal translation. Now, once again, the trigonometry math people have a very sophisticated way of saying that. This is also known as the phase shift. Right? Shifting left and right. Okay? Now, in this case, if c is bigger than 0, then it goes to the right. Now, I know some of you are like, what just happened there? Remember, if c is bigger than 0, the function is written as y equals f of x minus c. Okay? Now, that means that the c value is just this part here. So notice, you might want to say, well, if you see in the function it's x minus c, then it goes to the right. In this case, if c is less than 0, that means it's x minus negative c, right? Like negative. So that just becomes x plus c. So that's why when you see the plus sign, people think, oh, it goes to the left. Yeah. Okay. Once again, this is the weird one. You figure it out on your own. Make sure you figure out one way that works for you. Okay. Let's just quickly summarize all this stuff. You can determine the amplitude, the period, the phase shift, the vertical displacement of any sinusoidal function. Remember, sinusoidal just means sine or cosine. When the equation of the function is given in this form, okay, y equals to a bracket, or I guess not bracket, but a sine b bracket x minus c close bracket plus d. Okay, a, b, c, and d. What do these things have in common? Nothing much really, but they're all related together when we graph things out. Vertical stretch by a factor of a, so that's where a comes into play. It's the vertical stretch. Of course, if a is less than 0, we get a lovely reflection in the x-axis. Horizontally, of course, if you stretch that by a factor of, now once again, horizontal is weird, it's opposite of what you think. Counterintuitive, so it's 1 over b, and it changes the period to 2 pi over b. And of course, if b is less than 0, we get what we call a reflection. Okay. By the way, some textbooks will put an absolute value sign in front of the a and the b here, because they don't want you to look at the actual positive or negative sign. The positive and negative sign, of course, talks about the reflection. That's taken care of here and here. But like I said, some books will put the absolute value in front. So if you're seeing something like that in your textbook, it's the same. Okay. Horizontal phase shift is represented by the letter C. And of course, you go to the right if C is bigger than 0. Now, once again, I'm going to help you out by writing x minus C. And to the left, if c is less than 0, I'm going to help you out by writing x plus c. Okay. Vertical displacement is represented by d. And of course, you go up if d is bigger than 0, and you go down if d is less than 0. Okay? That's the summary. You get this stuff, it's pretty straightforward. So spend some time thinking about this, looking at this, absorbing this, memorizing this. Don't memorize, just understand. It's always good to understand. I hate memorizing. That's why I never did well in biology. Too much stuff to memorize. Alright, let's go to page 3 now of your notes. And I'm going to give you some practice now with putting everything together. Now, once again, in chapter 1, what did we have to do when we had all these things together? I hear some of you saying, Bert! Yep. Do the basic expansion, compressions, reflections, then translations. Well, guess what? It's the same thing here. So, I think what you should do is figure out the amplitude period, because that's the expansion compressions. In this case, I don't see any reflections. Then you'll do the translations after that. Okay? I'm going to be quiet and silent because I want you to try this on your own. Okay? Go ahead. I think the amplitude is 2. I'm going to do that first. The period, well, the b value is 0.5 or a half. So the period is probably 2 pi divided by a half, which is actually equal to 4 pi. Wow, this is wide. So I think I'm only going to do those two things first, okay? I'm going to take the regular cosine graph, which I know starts at 1, goes down to 0, then -1, then 0, then 1. That's the regular cosine. But wait, I'm going to try to change this. The amplitude gets doubled. So instead of starting at 1, it now starts at 2. Okay. Guess 0 still exists. -2, 0, and 2. But wait. The period gets actually doubled too. Oh, wow. So, maybe instead of using x's, I use big zeros or dots. Now, this one that used to be at pi over 2, I guess doubled becomes pi. This one at pi doubled becomes 2 pi. This was at, I think, 3 pi over 2 doubled, that becomes 3 pi. And then, this one up here at 2 pi becomes, 4 pi. So, big dots. Here's my graph. This is just temporary. This is the graph of y equals to 2 cosine 0.5x. This is, of course, the expansion and compressions only. Now I'll do the phase shifting and the vertical displacement. These are the translations. I'll use my purple pen. Phase shift seems to be I'm going 2 pi over 3 to the left. So that's left, right? And then because I have a -1, I guess I'm going down 1. Okay, 2 pi over 3. That means on my scale here, remember each dash is pi over 3. So I gotta go 2 to the left, so 1, 2, and then 1 down. Okay, 2 to the left, 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 1 down. Okay. Graph. And there you have it. Y equals to 2 cosine 0.5 x plus 2 pi over 3 minus 1. Ta-da. Okay. I guess since 1 I did, I forgot I was not supposed to do it for you. Maybe you should do 2 on your own. Okay? So once again, stop the video. Oh, wait. There's a weird thing to do. What's the weird part? If you thought about, that 2 there and how it's inside the bracket, I think that's a concern as well. How about we factor that out? And if you factor that out, I guess we get x minus, now remember you're dividing everything by 2, so 2x divided by 2 is x. The negative pi divided by 2 is just negative pi over 2. This now helps because, very easy now for me to determine all that stuff about the amplitude, period, phase shift, vertical displacement. And there's that negative in front too. Oh man. Some reflection thingamabobber too. Oh boy. Okay. I guess before I let you get started on this, let me at least help you create the scale. Okay? I think for us, since I'm going to go up 3, it's best if I leave more space going upwards. Let's see. Well, let's go ahead and at least graph something here. Let's just try something here. I want that to be moved down just a little bit. Move. Oh, too far. Okay, good. And then I'm going to draw the y-axis. Let's try it somewhere like here. I just know because I'm going to go right some units, so let's just try here. Okay, you can do the same thing. Okay, Alright, so there's my X, there's my Y. Now, by the way, you have to kind of decide what your scale is going to be. I know the one above, I used 3 spaces to represent 1 pi. The general convention is actually, it's better to use 6. So I'm just going to use 6, okay? 6 is better because you have all those pi over 6s, pi over 3s, right? That's why. So anyways, 1, 2, 3, 4, 5, 6. There's pi, okay? 1, 2, 3, 4, 5, 6. There's 2 pi. And I'll do one more. 1, 2, 3, 4, 5, 6. There's 3 pi. Okay. All right. I think I'm just going to use 2 squares for 1. 1, 2, 3, 4, 5, -1, -2. Okay. So I set this up for you. I'm going to ask you now to identify all these things: amplitude, period, phase shift, vertical displacement, and range too. Okay. And I'm also going to get you to graph this out. One last thing before I leave you. Remember our good friend Bert. All right. See you in a bit. Get to work. Once again, I'm going to split this up. I'm going to do my expansions first. So once again, I'm going to start with the regular sign. I guess I'll use green for regular sign. 0, dun, dun, pi over 2, 0. Yeah, pi over 2, 0. Whee! Alright, vertical compression, horizontal expansion. I'm going to put them all together using red, okay? Vertical compression, shrunk by a half. Dot, 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 dot. Oh, wait a minute. Horizontal compression, shrunk that by a half. Oh, okay, so, There you go. Okay? That's that first part. Okay? Red. Reflection in the x-axis. Okay, black. So this is graph number 2. Reflection x-axis, 0 still 0. Down there. Whee! That's pretty straightforward. Cool. Last but not least then, this is graph number 3, which puts them all together. Let's go right pi over 3. Now think about this. Each one of these things on the scale, let's see, 1, 2, 3, 4, 5, 6. So it's pi over 6. Pi over 3 is equivalent to 2 pi over 6. So I'm going right 2 units on my scale, and then up 3. So right 2, and then up 3. Now remember, each one is like 2, so okay, so up 3, yeah. So right 2, 1, 2, up 3. Oh yeah, up here. Oh, wait a minute. Oh. I'm supposed to be using the black one. Oops. So, oops. Right 2, 1, 2, and up 3. Right 2, up 3. Right 2, up 3. Right 2, up 3. There we have it. Done! Here's my graph of one cycle of that thing above. And if you're curious about the range, well, it looks like the range goes from a low of 2.5 to a high of 3.5. Cool. Alright, turn the page. Some food for thought. Something new, okay? I want you to think about this. It says, given just the A value, the amplitude value, and the D value, the vertical displacement, in the equation, how could you go ahead and find an expression for the range of these graphs? Okay? Draw a picture if you can help, and I'm actually not going to do this for you. Okay? You could try plugging in numbers, draw some pictures, but I'd like you to try this. Okay? Your job is to come back to class next day and actually show me what you thought. Okay? I hope you have thoughts. Don't leave the page blank. And if that's not enough, I know it's not, I've got another thought for you. What if I said this? If I just gave you the maximum value, or if I just gave you the minimum value. Sorry, not or. And if I gave you the minimum value in a sine or cosine equation. So given the max and the min value, how can you go about finding the amplitude and the vertical displacement? Okay? You can draw a picture or use the previous two examples to kind of help you out. All right, that's some food for thought. Think about it.